Daresbury is a UK national laboratory. We develop technologies for particle accelerators, which are then used for scientific exploitation. At Daresbury, from an accelerator perspective, the facilities you see here are the sort of cutting-edge machines that we're putting in place.
So we're attractive a partner in worldwide projects for two reasons. One is expertise and know-how, and the other is our facilities. We have very unique facilities that can both demonstrate, develop and do the research towards future accelerators.
The Large Hadron Collider is a giant particle accelerator built in Geneva under the Alps. It's the same size and depth as the Circle Underground line in London.
Now we've found the Higgs boson, we'd like to know more about it. To know more about it, we need to discover more of them, and to do that we need more collisions in the machine.
There are other rarer particles which may be being produced at the Large Hadron Collider, but not enough of them are being produced for us to detect. So we want to detect more of these events so we can discover things in a short time scale. So the UK is delivering some of the subsystems for this project. We are delivering what we call crab cavities, which are special radio frequency cavities which align the bunches so we have more chance of collisions. We're delivering collimators which take stray particles out of the beam so they don't damage things, because the LHC itself has the same energy as a jumbo jet takeoff. So if it was to hit a component, it would damage it. And finally, we're doing some of the diagnostics to track what the beam is doing.
So a superconducting cavity gives the benefit of providing very high acceleration for particle beams. They also provide a very low loss mechanism, so the RF power that you input to the structure, because of the characteristics of the superconducting device itself, means that it's highly efficient.
The reason engineers are involved is the scientists tend to have the big ideas and ideas of how we're going to improve the machine, but the engineers are required to actually implement this. So the engineers tend to be involved more on the detailed side of things.
The European Spallation Source is a €1.9 billion project in Sweden to build the world's largest proton linear accelerator. The European Spallation Source is often billed as the world's largest microscope, so this allows for interesting science in material science, for looking at things like new composite materials, or looking at pharmaceutical materials or life sciences. So the UK is looking at 6 or 7 different projects, 4 of which are based at Daresbury. I'm involved in 2 of the projects here, so I'm project manager for both the RF distribution system and the warm Linac modules. Both projects have been running for the last couple of years now. We've started production on all of the warm Linac units, so we're shipping out our first warm Linac unit straight to Sweden, so they're our first production units that we've sent out.
ELI-MP is one of 3 facilities which forms part of the Extreme Light infrastructure. It's a project which is funded by the EU and the Romanian government. It's currently being built in Magurele in Romania. The idea behind it is that we have a high intensity tunable gamma source
that combines an electron beam and laser to produce the most intense, brilliant gamma beam facility in the whole world. The UK are making part of this accelerator because Daresbury Laboratory has over half a century of expertise in making accelerators and are world leaders in producing electron accelerators in particular.
We're trying to develop unique engineering solutions for what the next generation of facilities need. Having the appropriate levels of engineering specialisms is critically needed for coming up with an appropriate solution.